guys, it's Ms. Z. We're going to be starting the first online section that we're doing. It's 8.5. So in this section, it actually talks about inscribed angles and its intercepted arc. Let's just explain real quick what an inscribed angle is. If you see over here, this angle right here is going to be an inscribed angle. It just means an angle inside that we have B is going to be our vertex. Our vertex of this angle is just on the circle compared to the central angles when the vertex was in the center, okay? Its two sides here are going to be two chords, and this creates an arc in here, and we're going to call it the intercepted arc, okay? So we got the inscribed angle and its intercepted arc. So here we got an inscribed angle is an inscribed angle is an angle with its vertex on the circle and two sides that are chords. An intercepted arc is an arc that lies between the endpoints, so here and here, of an inscribed angle. The measure of the inscribed angle is equal to half the measure of its intercepted arc. For example, I just put 30 as its inscribed arc. If this is going to be 30, this arc is going to be 60, okay? So this arc is equal to double the angle, and the angle is equal to half of the arc. A lot of times we're just going to say it as half, okay? So we have the measure of the inscribed angle is equal to half the measure of its intercepted arc. So for example, angle ABC, the measure of it here is half of the arc AC. Moving down to something that just comes out of this property is the fact that if we have diameters. Obviously at this point we know that a diameter is going to give us 180. If you look, BC is 180. Its arc here is also going to be 180. But what happens is if you start talking about the actual inscribed angle here, which would be angle BAC or CAB, its actual angle talks about the intercepted arc that is 180 degrees. So what happens if its arc is 180 degrees? Its angle is going to be half of that. Half of 180 gives you 90. So anytime you see a diameter, this is something that we should be thinking about. Is its inscribed angle lying right on the diameter? Well, yes, it is. So in this case, that would be 90 degrees. So our fill-in is, if an inscribed angle intercepts a diameter, then it is a right angle. So the measure of angle BAC is equal to 90 degrees. Okay? Last part here is the overlapping arcs. Pretty much what this means is if one of these angles creates this arc and the other angle creates the exact same arc, the angles are going to be equal. So we have if two inscribed angles intercept the same arc. So if we see, we have angle ABD. Over here, ABD, this is its angle. I extend it to see where its arc is. Its arc is going to be AD. If I look at this other inscribed angle, I get angle ACD has the exact same arc, which is still AD. Well, if this is, let's say, 50 degrees, both of these angles have to be 25. So what do I know about the two angles then? They're going to be equal to each other. That's pretty much the notes for this. We're going to apply it in the practice problems right after this. Hi everyone, we're going to start the practice problems. You should try these on your own before you actually go through the solutions. However, we're going to just go through all of the practice problems real quick. So what I end up seeing is, in this case, they're asking for the measure of angle WXY. So they actually want WXY. So that's going to be this part here. I look to see, that's going to be an inscribed angle. I can see that this and this is going to create its intercepted arc. Its intercepted arc is 62. We know its intercepted arc is double the inscribed angle. So what I want to do is I want to take this 62 and I want to multiply it by 1/2. And in this case, I'm going to get 31. And my answer here, in this case, is going to be 31 degrees. Okay, we're going to start example 2. Example 2 wants us to find the major arc DGF. So I look at the two endpoints of the arc at once. I highlight, okay, DF, it has to go through G. So it's going to have to go this way. So I want that arc. So we know we're going to be working with inscribed angles, so I'm going to see where that inscribed angle is. For example, it's going to be here and here. Okay, so what do I know about its arc? The arc is going to be double the inscribed angle, so I'm going to just take this 113, multiply it by 2. I'm going to get 226. I'm going to put 226 degrees, and that, in this case, is going to be my answer. Next one we get here has this picture, and we see, first thing that I see is that PR is this diameter. I know that because it goes through the center S. What they actually want is the measure of angle PQR, so PQR. So I'm going to just mark that right here. If this is 180 degrees, because of the fact it's a diameter, this part is going to be 180 degrees. I'm going to look to see where its intercepted arc is. And in this case, it's the full 180 degrees. Well, I know the arc is double its inscribed angle. So I'm just going to take this 180 and multiply it by 1/2, which gives me 90 degrees. So in this case, my answer here is going to be 90 degrees. Moving on to number 4. I look to see what they actually want. They want the measure of arc BC. Now, I don't really know much about that at all. However, I do have this 47. Let's see at least what we can do with the 47. So the 47 right here, if I extend these lines, let me find its arc that it relates to. And in this case, it's that. So this is 47. I find this arc by multiplying by 2. So I'm going to take this 47 and I'm just going to multiply it by 2. And that gives me 94 degrees. So this here is 94 degrees. I don't know much about BC. However, I do know that this arc is going to be 180 degrees because AB is a diameter. So this whole thing has to add up to 180 degrees. So I have this part, which is 94 degrees. So I'm going to take 180 and I'm going to subtract off 94. In this case, I get 86 degrees. I see, okay, well, this would be 86. Is that my answer? Yes. So I'm going to put 86 degrees right down there as my answer. Number 5 starts to get a little bit trickier. Let's look for what they actually want. They want the measure of angle JKL. So JKL is right here. As of right now, I look, okay, what do I know? Well, its arc is going to be all the way around here. Okay? So we have that major arc there that we don't know anything about. So let's see what we actually do have. Right now I have 53 is here and 65 is here. So pretty much we have everything other than what we actually want. So what am I going to do? Well, we know all of it adds up to 360 degrees. So what I'm going to start by doing is taking 360 degrees and subtracting off 65 and 53. And in this case, when we do that, we get 242 degrees. I'm going to put that right over here as 242 degrees. I'm now going to look at what I actually want. Well, I want its inscribed angle. The arc is double the angle. So what I'm going to do here is I'm going to multiply it by 1/2 to get its angle. So I have 242, and I'm multiplying it by 1/2 to get 121. I look, that's 121. Is that what I actually want? Yes. So I'm going to put 121 degrees here. Moving on to number 6. So this one ends up being kind of cool. It's the first example where we see overlapping arcs. So here I have 64 degrees, 139 degrees, and 75 degrees. You can probably already see that potentially I might be finding this at some point. But let's look at what we actually want. They want the measure of angle RST. So I look RST, that's this inscribed angle. Let's look at where its arc is. So its actual arc right now is going to be RT. So let me look. I can figure that out. I know all of the outside adds up to 360. I'm going to subtract off everything else. So here I'm going to start by doing 360 minus 75 minus 139 minus 64. And that gives me an answer of 82 degrees. I'm going to put 82 degrees here. That's its intercepted arc. I want to find the inscribed angle. The inscribed angle is half of it. So I need to take this 82 and multiply it by 1/2 to give me 41 degrees. So this is 41 degrees. I can go down and actually write my answer here, 41 degrees. I'm going to look at the next part here, which is going to be angle RUT. Angle RUT. So that's this angle right here. I'm going to extend this out, see what I got. So this is pretty cool because of the fact that it actually shares the exact same arc. This was 82. How do I find this angle? Well, it's going to be half of it, 41. I shouldn't be surprised that the two are equal to each other because of the fact that they share the same exact intercepted arc. So both answers here are 41. Okay guys, we're getting into the part that they add a little bit of algebra into it. First couple should be more of your basic questions. We'll get into a little bit more tricky, but for right now, let's just see what we got. So looking at this, what we have here is this angle that's going to have the same relationship as its intercepted arc. So what do we know? We know the inscribed angle is equal to half of the arc. So the inscribed angle is equal to half of the arc. So here we're just going to do a little math gymnastics. We get 78 or 79. When we multiply that, we get 8x minus 9. Add your 9. Add your 9. These cancel out, giving you 8x equals 88. Divide by 8. We get x equals 11. Just going to put that down here. Moving on to the next one, we have question number 8. Make sure you can see that. So it's the same concept here. We have the angle, we have its arc. So what do we know? Same thing, the inscribed angle is equal to half of the arc. So the inscribed angle is equal to half of the arc. Now looking at something like this, I can distribute the 1/2. I'm fine with doing that right now because of the fact that both of those numbers are even. So we have 67 equals 2x plus 29. Moving on, I'm going to subtract 29, subtract 29. These cancel out, leaving me with 2x equals 38. Dividing by 2 on each side leaves you with your answer of x equals 19, and that's just going to go in the answer. Moving on to this is one of the questions that we get that uses the diameter, so I already know this is 180, this is 180. We have this angle here. Let's see where its arc is, and it is. This is going to be 180 degrees. We can set up the full equation, but honestly, we already know that this is going to be 90 degrees. So let's just set up 13x minus 1 equals 90. Add 1, add 1. I get 13x equals 91. Divide each side by 13. I get x equals 7. Just fill that in over here as my answer, and we're moving on to number 10. This one's a little tricky because of the fact that it almost looks like it should be a diameter. It's not. It doesn't go through the center. Let's see what we have. So here, I'm given this angle. I apologize. That's a pretty bad arrow. It means this angle here. So we have this angle, we have this angle, and we have this arc. This arc goes back to this inscribed angle. The arc is double the angle. So what I'm going to do is I'm going to take that 78 and I'm just going to multiply it by 1/2. And in this case, when we multiply it by 1/2, we get 39. I'm going to put that in here. So looking at what we have, I then see, okay, well, I have this angle, I have this angle, and I have this angle. This is still just a triangle that adds up to 180 degrees. So that's going to help me set up this equation. I'm going to say 39 plus 114 plus 7x plus 6 equals 180. I'm going to do a little math gymnastics here by combining my like terms. In this case, I get 275. I am totally lying here. That's the other problem. This is going to give me 159 plus 7x equals 180 degrees. I'm going to subtract off the 159, subtract off the 159. Here I get 7x is equal to 21. Go ahead and divide each by 7. I get x is equal to 3. And that's what they wanted, so that's my answer. The thing about this is some of you might have taken 180, subtracted off the 2, and set this equal to that. As long as you still got the same answer at the end, it's fine. In number 11, we're going to look at what we have. We're definitely going to be using this angle. It's an inscribed angle. Let's look at where its arc is. As of right now, we know absolutely nothing about its arc. However, we have the other two arcs. So we know the whole thing adds up to 360 degrees. So what I'm going to do is I'm going to subtract off the 162 and the 92 from both. And we're going to get 106. I'm going to put that up here, 106 degrees. Now what do I know? Well, I still know the inscribed angle is equal to half of the intercepted arc. So the inscribed angle, so 7x minus 10, equals half of the intercepted arc. Let's multiply this by 1/2. We know half of 100 is 50. Half of 6 is 3, so we get 53. 7x minus 10. Little math gymnastics. And we're going to get x equals 9. That's what they actually asked for, so I'm just filling in my answer there. Looking at number 12, similar concept here as they did in the last one. I have this inscribed angle. I don't know anything about this. We already know how to find this. The angle is half of the arc, so let's just double it. So we're going to take 67 and we're going to times it by 2 to get 134. I'm going to put that 134 here. What do I know? Well, all three of these have to add up to 360. So what I'm going to say is 120 plus 134 plus 5x plus 21 is equal to 360. Combine your like terms. Here you're going to get the 5x plus 275 equals 360. Subtract off 275, subtract off 275. I get 5x is equal to 85. We're just dividing each by 5. We get x equals 17. And let's throw that as our answer. Hi guys, we're going to start some of the ones that you actually have to fill in the angles and the arcs into the problem. So for example, this one we have the measure of angle FGH, so FGH, so this is going to go right over here. This is 6x plus 21. And measure of arc FHJ. So I'm going to look at F, I'm going to look at H, and it has to go through J. So that's this way. That is going to be 17x minus 28 degrees. So what do I know here? It's the same as before. The inscribed angle is equal to half of the arc. So the inscribed angle is equal to 1/2 of the arc. Make sure that this is the actual angle. That's its actual arc. And in this case, if you extend those out, it is. Now here's the one thing about this. Yes, you can multiply the 1/2 into both. But the thing about that is 17 is not an even number, so it's not going to be a pretty number. So I want to get rid of the 1/2. Currently it's multiplied by 1/2, so how do I get rid of that? I'm going to multiply both sides by 2. Over here, the 1/2 and the 2 will cancel, leaving me with 17x minus 28. On this side, the 2 is going to go into both, leaving me with 12x plus 42. And then we're just going to solve. So I'm going to subtract 12x from both sides. I get 42 equals 5x minus 28. Add 28. Add 28. We get 5x is equal to, and let's see, 0.770 there. I'm going to divide each by 5. I get x is equal to 14. However, that's not actually what they want. If you look, they actually want the measure of arc FJH. And if you look back up at the top, they already give you it as 17x minus 28. So I'm just going to plug this in to that. So instead of 17x, I'm going to have 17 times 14, which is my x. So I'm just substituting in here. When you do that, you end up finding the answer of 210 degrees, and I'm going to just put that down here as my answer. Moving on to the next one. Same thing, let's start out by just filling in what they give us. They give us the measure of angle STU, so right in here is 5x minus 16 degrees. Over here, arc SU is 12x minus 50. Same thing, still degrees. Let me look here and here. Yep, this is the inscribed angle and its intercepted arc. So I go by the formula that we know. In this case, the inscribed angle is equal to half of its arc. Both of these numbers here are even, so let me just put my 1/2 into both. I get 5x minus 16 equals 6x minus 25. I'm going to subtract 5x from each side. I get negative 16. Don't forget to carry down that negative. Negative 16 equals x minus 25. Add 25 to both sides. And in this case, I get x equals 9. Yet again, make sure you get the full amount for this question by looking that they don't actually want that. They want the measure of angle STU. And yet again, it ends up being a problem where they already give you the measure of angle STU as 5x minus 16. So all I'm going to do here is plug in my x. So here it's going to be 5 times 9 minus 16. And when you do that, you end up getting 29 degrees. Make sure you put the degrees on there since they're not asking for the variable, they're actually asking for the measure of the angle. On to this one, let's just fill in what we have. The measure of angle ABD. So right in here is going to be 6x plus 26 degrees. Over here we get measure of angle ACD. So ACD over here is 13x minus 9, yet again degrees. So far I don't really actually have any angles around, so let's see how these two are related. So I'm gonna look here, let's see where its arc is. So its arc is gonna be AD. Okay, still don't know anything about that. Let me just go ahead and check the other one. Let's see what this one's arc is. And in this case, that one's also AD. So this is the case where we have overlapping arcs. Okay, if their arc is the same, their measure has to be the same. So what should we know about the two? Is that both are equal to each other. So that's how my equation is going to be set up here. I'm going to have 6x plus 26 equals 13x minus 9. Just going to go through and solve. I get here 26 equals 7x minus 9. I'm going to add 9. I get 35 equals 7x. Divide by 7 on each side. I get x equals 5. Yet again, not done. We still have to plug it in. So they want the measure of arc AD. I don't actually have anything to represent that. However, I do know the relationship between the arc and its angles. Plug it into whichever one you want. I picked this one because of the fact that it seemed easier. So here I'm going to go and have 6x plus 26. Let's fill in our x. It's 6 times 5 plus 26. And in this case, when you have that, you get 56 degrees. Let's plug it in out here. In here, 56 degrees. Okay, so going back to the original equation that we're given, the inscribed angle is equal to half of the arc. So we need to take this and double it to get the arc, which is exactly what they wanted us to find. So all I'm going to do is take that 56 and multiply it by 2. And in this case, I get 112 degrees. Put that as my final answer. Make sure you put your degrees on there. Last one in this part of the section. What we have here is, first thing I see is already, okay, I'm seeing a diameter here. So, looking at this, let's fill in angle KJL. So, KJL. This angle right here is going to be 3x plus 2. Over here, I get KLJ. KLJ, so this angle is 7x minus 32. I don't really know anything about the 2. However, going back to the fact that this is diameter, aka this is 180 degrees. If you look, this is 180 degrees, so let's look at its angle. Its intercepted angle is right there. It has to be half of it, so in this case, you get a 90-degree angle. Two ways that you can set this thing up is saying this plus this equals 90, or I'm just going to go with the 3x plus 2 plus 7x minus 32 equals, I'm sorry about that, plus 90 equals 180, because I have a feeling most of you set it up adding all three of those and setting it equal to 180 because of the fact that it's a triangle. So let's look at this and let's just combine our like terms. When you end up doing this problem, you get your x's to add up to 10x, your constants to add up to 60 equals 180. We're going to subtract 60 from each side. I get 10x equals 120. Divide by 10, divide by 10. X is equal to 12. Yet again, not done, but we're almost there. They actually want arc KL. So let me just highlight that real quick with my highlighter to make sure I can see. Okay, so KL is right here. So let's look at where its arc would be. Its angle, sorry about that. So its angle is going to be right in here. So let's plug it into this one and see what we can do. So when I plug that in, I end up having 3x plus 2 is the same as 3 times 12 plus 2. And in this case, when you plug that in, you get 38 degrees. And I'm just going to put that right over here. So I get 38 degrees there. How do I find its arc? Well, its arc is going to be double it, so I'm going to take 38, and I'm going to multiply it by 2. And in this case, I get my final answer is 76 degrees. Plug it into the bottom there. And make sure you don't forget your degree sign.